So you need a blank piece of paper and something to write with today. Blank piece of paper, something to write with is what you need for the day. Wow, you guys are prepared. Oh, I've got leftover homemade pizza for lunch. I make a mean pie. I go for a little deeper dish on my crust. Who likes deep, like a thicker crust on their pizza? Okay. Who likes thin crust?
What are we talking about?
Pizza. So you're more of like a Bosco's fan? Hollyana, where do you get your pizza?
Pizza Hut.
Pizza Hut. You get thin crust? Okay. Willie, where do you get your pizza? Little Caesars. Okay. Have you tried their new thin crust pizza?
Yeah.
Okay. Okay, Friday. Do you remember what we did? We did a lab. Yes. And what did we do on that lab?
Measuring stuff.
If you remember, I drew this picture before class, right? You guys remember when we drawn these cones? Yes? So we had two cones that were exactly 1 meter apart. Yes? And then we had a set of cones that was semi-far apart, and then another set of cones that was much farther apart. Do you guys remember that now? Head nod if you remember that now. Okay, now you're with me. Okay, and then I told you I wanted to know the distance between these cones and between those cones. Does that ring a bell?
Yeah.
Yes, okay, good. So, when you got out there, what was the first thing that you did? What was the first thing you did? Anybody? Scout. Okay, measure the 3 meter cone. Okay, anybody else? What was the first thing you did? No one else has a first thing they did. Can you think back that was 3 days ago? Yes.
The first thing that we did, right?
What was the first thing you did when you got outside?
Measured 1 meter, like with how many steps.
Measure the 1 meter. Montier, what was the first thing you did? Measure the 1 meter. Anybody else? Everybody just jumped in. Did anybody do anything different than measure the 1 meter? No one did it? Okay. Has anybody here ever heard, oh, I don't like that. What color do you guys want to write in today? Pink? That's gotta be hard to see.
Blue.
I'll go blue. I'll go blue. Have you guys ever heard of the scientific method? Have you guys heard of this?
Sometimes.
Okay, you guys have heard of this. Okay, scientific method. You guys can write that down if you want. Yeah, you probably should. Scientific method. Does anybody know what the first step is in the scientific method? Because no one here has said that they did it. Everyone here said that they had those two cones and they just started.
Make a hypothesis.
Not make a hypothesis. Before that.
Make an educated guess.
That's the same thing as a hypothesis.
Set up a procedure.
Not yet. Observe. Did anybody think, okay, I'm just asking, now that you're like, now we're thinking. So the first step in the scientific method is to observe. Did anybody look at the set of cones, the distance, and think, I don't know, it looks about between 30 and 50 yards? Like, did anybody think that, like football? Nobody even thought about that. Did anybody look at anything before they started? Did anyone? Yes, what'd you look at?
So I was looking at like two cones, trying to like figure out it would be.
Okay, good. Lyra, what were you going to say? Same thing. Jocelyn?
I was like trying to think how many meters were in that.
Trying to think how many meters might be in that. Okay. So most of you said that you just jumped in. Daisy, did you observe anything? No. Did anybody else think they observed something? Now that we've thought about it, did anybody observe anything before they started? Yes.
Just like the cones in general.
What about the cones?
The distance.
Okay. Some people asked, is it from the tip of the cone to the tip of the cone, middle of the cone? Yes. Anybody ask me that? Okay, somebody did. I forget that. Anybody know the second step in the scientific method? Second step. Ken's.
Research the problem.
Research the problem. Yeah, that's pretty good. 2, I would say state the problem. State the problem. What was, thinking back to our lab on Friday, what was the problem?
How many steps?
Not how many steps.
How many meters it was?
How far apart were they, right? Do you guys agree that was the problem? The problem was you had two sets of cones that we did not know how far apart they were. Did we state the problem? Yeah, we did, right? We didn't do this in order, but before class, right? Before we went outside, I drew the cones, yes. Did I state a problem for you? Yes. So it's a little bit out of order, right? You knew you were going to go outside, you knew that there were two cones a meter apart, and the problem was, what's the distance between the farther cones? C? Yes, okay, good. How did the cheerleaders do, at least in the football game? Did the cheerleaders do okay? Are you a cheerleader, Aliana? Did you guys do well? Okay. Better than the football team? Okay, what happened? I did not expect for us to lose to Orville. Did you, Mr. Durbin? No.
No, I thought it was supposed to
Yeah. Julian had a big game. Julian had like what?
be. Yeah, fantastic.
200 something yards rushing?
My dad said it was the defense.
I think it was the offense.
The offense fumbled a lot.
The offense was not blocking.
Who do we play this Friday?
Kent Roosevelt.
Are they good?
We Roosevelt.
They sound like they would be, kind of sounds like they would be good. Is that private or public? Kent Roosevelt? I bet they're good.
Their softball team is good.
Okay. All right. Observe. State the problem. Someone already said third step. What's the third step? Hypothesis. The third step is make a hypothesis. And we know that a hypothesis is a what? Educated guess. A hypothesis is an educated guess. Did anybody make a hypothesis in their head, now that they're thinking about it, about the cones? Caden, you did? What was your hypothesis?
I was thinking like how many steps. I was like trying to guess on how many steps I would think it would take.
Guess how many steps. What else? Even more simple than that. What's the most simple hypothesis you could have made on that Lab Friday? Did you want to try, Lyra? Ariana?
I don't know.
What would be the most simple hypothesis based off of the 1 meter cones that you could make? Yes.
They have like 1 meter in it.
What?
They have a meter in it.
We knew that those two sets of cones were larger than what? We knew they were longer than a meter. Would that not be a hypothesis? Yes? And we know that they were shorter than what? What would you say that we knew that they were shorter than? What's another mark? The cones, the bigger cones, were shorter than a football field. Would you guys agree? Yes? So that's what I would think when I was going out there. Okay, I know it's longer than a meter because I have a meter marked. I know how long a football field is. Or did anybody watch the 100-meter dash at the Olympics this year? Nobody watched the 100-meter?
I was about it.
The highlights? Did you guys watch it? Did you guys watch the Olympics? What? Well, everyone saw the breakdancing girl. That was like the meme of the Olympics. Mr. Durbin, do you watch the Olympics?
I watched the races. I thought those were a lot of fun. That and basketball.
Oh yeah. I don't even like Steph Curry, but you had, I mean, that lap. Did you see the gold medal game?
That was a fun one.
That was cool. Yes, so a hypothesis could be it's greater than a meter. Or a hypothesis could be it's less than 100 meters. Or you could say a hypothesis could be it's around 30 meters. So you should be making a guess. Okay, this fourth step is where I think you guys all jump to. Anybody know what the step is after hypothesis?
Try your hypothesis.
Test the hypothesis, yes. You're going to test your hypothesis. You're going to test your hypothesis. Most of you got out there, you saw the two cones, and what did you start doing? What? You started figuring out the distance between those 1 meter cones, yes? Most of you started to like step 4 without even doing the first 3. So that was kind of the point of the lab, is just start thinking about scientific method. Okay, we're testing the hypothesis. What's the 5th step? Scientific method. Yes. How about Caden? Cole. Okay, and how would you see if it was correct? What would I have to write down? Record results, right? Yes. So let's say record data. So we're recording data or we're testing our what? Hypothesis, yes. Connor, did you record any data? What kind of data did you record?
How long the drive was based on its depth of field.
Okay. Did anybody else record any data on Friday? Raise your hand if you think you recorded data. If you wrote down numbers, you recorded data. Come on. Who did? Okay, good. Okay, so we recorded data. I like that. After I have data, what's the next step? Sawyer?
Test again.
Not test again. Yes? Make a conclusion. Yes. So I have to, I'm going to say draw a conclusion. Now let's just say conclusion. So we have to make a conclusion. So a conclusion is, what is my thing I'm concluding? And what was our conclusion in this lab? Our conclusion was, how far apart were the cones? And some of you got pretty close, right? Yes. Some of you did not get close, but that's okay. There's one more step after this in the scientific method. What is the last step after this? Kind of.
Compare.
Kind of. That's part of this. Ken's?
Extend the experiment and write down your work.
So we've already recorded our data. I have a conclusion. Yes? Repeat. Yes. Step 7 is to repeat. Who here is planning on discovering a cure for cancer in their lifetime? Nobody? Does anybody want to discover, would anybody want to discover a cure for cancer in their lifetime? Okay, Ariana says yes. Okay, good.
I mean, if I did, I wouldn't mind.
Do we agree that cancer is the worst? Yes, okay. So, I've had multiple family members affected by cancer. Ariana is going to discover a cure for cancer. All right? First of all, she's going to be rich. All right? She's going to be rich. Second of all, if she says she discovers a cure for cancer, will people believe her? Will the scientific community believe her?
Probably not.
Probably not. Why?
She doesn't have evidence to back it up, and no one has been able to do it.
Anybody could say anything, right? I could say that I hit 100 home runs in Major League Baseball last year. Could I not?
Yeah, you could.
I could, but how would people believe me?
They wouldn't.
But how could they believe me?
Oh, you should.
If I could repeat it. If I could walk on to the Guardian squad right now, and if I could hit 100 home runs, I guarantee you I would be on the team next year. Which, that doesn't, I don't know. Does that sound fun? For me at this point, like, I'd just be gone from my family. I don't know. I guess the money would be nice.
That would be a lot of money.
Be a lot of money.
You could hit 100 home runs in a season.
Yeah, I guess I could, if I do it for like 2 seasons. Yeah, I'll go 2 seasons and then I'll just retire. What's enough money? Have you guys ever thought about that?
No.
Like at what point, if you had, like, at what number would you have to get to just stop?
Like just to be set off the rest of your life.
Yeah,
Like 5.
5 million?
That's-
Okay, that's crazy that people are like, that's it. If you had $5 million right now and you just invested that and like, got 4% interest on that,
House right now is $350.
yeah, that's fine. I think if any one of you had $5 million and you were smart with it, you could be set.
Okay, but I'm not
Are we
smart.
talking about like living luxuriously or just living a
Just
casual
like
life?
living.
I would just say living.
Yeah. And if you invest it correctly, then you'll just
If you invest $5 million and you get 4% interest on that a year, so think about that. 10% interest on 5 million is what? 500 grand? So your 4% interest is going to be like 380,000 a year. Do you think you could live on that?
maybe.
Maybe. Okay. You guys better get really good jobs. You better get real good jobs. How do we get on that? Cancer. Okay. Ariana discovers this cure for cancer. People in Europe are going to say what to Ariana?
No.
No, they're not going to say What are they going to say? What? Prove it. So then Ariana is going to have to say, here's my research, here's my data, I collected all this. She hands it over to people in Europe, and they can repeat it. Okay, well then the people in, where else? Australia are going to want to see it. So they're going to take the data. They're going to repeat it. And once scientists around the world repeat, guess what?
Then people are gonna,
It's proved.
yes.
Ariana's super famous. She's going to be like, I had the science teacher in ninth grade, Mr. Heller. He inspired me to discover the cure for cancer. And she's going to name the drug Hellarium. Like, kind of cool. Or whatever you want to. You can name it after yourself. The Ariana cure. That's kind of cool. Does anybody here want to go to a medical field? Okay, one person. Two? Okay. Okay, cool. But you have to be able to repeat. Questions about scientific method? Okay. So, put a little line through your paper there. Put a little line through your paper. Is there the other thing I noticed out there is, from our lab, you guys are writing down data. I had data in all different ways. Some people were like counting their feet out. How'd you guys get your numbers? Somebody. Share how you got your number. Scout, how'd you get your number?
Paces,
Paces, then what?
then we, took how many paces, divided it by 3 and 3.5 actually, and then that was our number.
So Scout took paces, he divided by 3.5, that was his number. Who else has a different system than Scout? Lyra.
Daisy walked it, she just, it was 4 feet. and
Okay.
We walked all the way, we counted how many steps, and we divided it.
So they were measuring in Daisy steps. Agreed? How many of Daisy steps was 1 meter? 4. Who else was measuring in a different system? Ariana?
I was just using my feet.
Using your feet? And what was your measuring system?
5.
So we had 5 Ariana feet. Was a meter. So I have 5 Ariana feet. I've got 4 Daisy feet. I have 3. Was it 3.5 Scout feet? Yes? Willie?
So every step I took was a meter.
Every step you took, yes. And then we had the Willie step. That was like massive. All right, because Willie is probably the tallest person in the room. Is it good that if we were trying to repeat this, and we have all those different measuring systems, would that be a good system to work with? Probably not, because it'd be 4 different measuring systems, yes? Could we say that 1 Willie step, you don't have to write this down, is equal to, how many was it, Ariana? How many, was it 5? Is equal to 5 Ariana steps, or feet, that was feet. Do we know if those were exactly correct? No. Okay, you could write this down. Could we say that 1 foot equals 1 pound equals 1 gallon? Does that work with our system?
No.
Can we say that 1 foot equals 1 pound equals 1 gallon?
No?
Does that even make sense?
No.
Anybody know what this system is called? The system that we measure with.
Oh, sure.
The metric, no, not what, we don't measure with metric system.
Um,
The English, also known as the, starts with an S, ST, the standard system. Yes. We measure with the standard system here in the United States. This system is dead to us. This system is dead to us. Do you know how many other countries still use this system?
A lot.
us. 0.
I believe there's 1 or 2 other countries. I've got a video to show you. This is crazy. This is going to blow your mind, I think, a little bit. All right, let me pull up this YouTube video. Okay. All right, plug in here, and we're ready to rock. Okay, switch. That is not it. We need HDMI. Here we go. By this time the ad should be over. So
My writing partner helps. Grammarly will start highlighting the stuff that you could do better. Your professor would destroy you for that. But with Grammarly, you can find it and fix it. Grammarly will notice the grammar and spelling mistakes, but also places where you're rambling or your point could be clearer. Okay.
What does the French Revolution have to do with the time NASA accidentally crashed a $200 million orbiter into the surface of Mars?
Did anybody know that NASA once accidentally crushed a spaceship into Mars? Has anybody heard of this? So they were trying to, what?
Ever heard of the Jupiter one?
I have heard of that. So they were trying to land this orbiter onto Mars, not into it. This was a $200 million project, and they crashed it. Any guesses of why it crashed? Sawyer.
Gravity?
Not gravity.
Is that pole? Whatever that's called.
So it's using thrust to go against gravity.
Too much like speed. They didn't calculate it right.
Something about a calculation.
Much drag.
Keep watching. Keep watching.
Actually, everything. That crash happened due to an error in converting between two measurement systems, US customary units and their SI or metric equivalents.
So the thing that's cool about NASA and space travel, right, is it's worldwide. There's people all over the world working on this. Somebody in the United States, or I don't know where it was, forgot to convert from inches to centimeters. And guess what? How far away are these missions? How many miles away is Mars from us? Hundreds of thousands of miles. Do you think that inches versus centimeters could matter over a huge distance?
Yes.
Yes. So because someone forgot to convert, guess what? Boom, $200 million gone. One conversion. Check out the rest of this. This is a pretty cool video.
So what's the connection to the French Revolution? Let's explain. For the majority of recorded human history, units like the weight of a grain or the length of a hand weren't exact and varied from place to place. And different regions didn't just use varying measurements, they had completely different number systems as well. By the late Middle Ages, the Hindu-Arabic decimal system mostly replaced Roman numerals and fractions in Europe. But efforts by scholars like John Wilkins to promote standard decimal-based measures were less successful. With 250,000 different units in France alone, any widespread change would require massive disruption. And in 1789, that disruption came. The leaders of the French Revolution didn't just overthrow the monarchy. They sought to completely transform society according to the rational principles of the Enlightenment. When the new government took power, the Academy of Sciences convened to reform the system of measurements. Old standards based on arbitrary authority or local traditions were replaced with mathematical and natural relationships. For example, the meter, from the Greek word for measure, was defined as 1/10,000,000th between the equator and North Pole. And the new metric system was, in the words of the Marquis de Condorcet, for all people, for all time. Standardizing measurements had political advantages for the revolutionaries as well. Nobles could no longer manipulate local units to extract more rent from commoners, while the government could collect taxes more efficiently. And switching to a new Republican calendar with 10-day weeks reduced church power by eliminating Sundays. Adoption of this new system wasn't easy. In fact, it was a bit of a mess. At first, people used new units alongside old ones, and the Republican calendar was eventually abandoned. When Napoleon Bonaparte took power, he allowed small businesses to use traditional measurements, redefined in metric terms. But the metric system remained standard for formal use, and it spread across the continent, along with France's borders. While Napoleon's empire lasted 8 years, its legacy endured far longer.
So what does this have to do with us? This is wild what it's about to show you. All right? So what does this have to do with us over here across the pond? Check this out.
European countries reverted to old measurements upon independence. Others realized the value of standardization in an age of international trade. After Portugal and the Netherlands switched to metric voluntarily, other nations followed, with colonial empires spreading the system around the world. As France's main rival, Britain had resisted revolutionary ideas and retained its traditional units. But over the next 2 centuries, the British Empire slowly transitioned, first approving the metric system as an optional alternative before gradually making it official.
Okay, so Britain, right? Britain doesn't approve it. They're one of the last ones to approve it. Anybody know where the Pilgrims were from?
Oh,
Britain. You guys aren't that far in history. It's only like day 4. It's fine. All right? The Pilgrims came over on the Nina, the Pinta, and the Santa Maria. Yes? They came over from Britain. For what reason? Why do people leave
Because it
England? Religious freedom, right? Yes. So they come over on these boats, but guess what system they bring with them? It's still the old system. Yes. So it's still the old system.
However, this switch came too late for 13 former colonies that had already gained independence. The United States of America stuck with the English units of its colonial past, and today remains one of only 3 countries which haven't fully...
Only 3 countries in the world still use standard. Yes.
Actually, one of the presidents back during like, the first couple of years of independence tried to induct the metric system, but they were stopped by. So the ship that was carrying the metric system stuff was hijacked and taken over by British private Navy people, and so basically like they pirated all that stuff off them, and until it never made to the U.S. So if that was gone, they probably would be using metric system.
I had no idea. That's actually kind of cool. So do you guys hear what Connor said? Connor said that they were bringing a ship over with all the metric materials they needed, but then pirates, right? Navy pirateers attacked the ship, and the metric stuff never got here. So Myanmar, Liberia, and the United States of America are the only 3 countries still using foot, pound, gallon. Dang. I know.
the metric system. Despite constant initiatives for metrication, many Americans consider units like feet and pounds more intuitive. And ironically, some regard the once revolutionary metric system as a symbol of global conformity.
How is a foot or pound better than the metric system? How does the metric system work? What do you have to do to convert? Divide by what? 10. Yes. Does 17.542 inches mean a lot to us when I could just have 171 centimeters is 1.71 meters? Which one's easier, first or second one? Second one, right? Who here likes dividing by 10? Okay. Who here likes dividing by 36? Yeah. So I think that the metric system would make a lot more sense.
Nevertheless, the metric system is almost universally used in science and medicine, and it continues to evolve according to its original principles. For a long time, standard units were actually defined by carefully maintained physical prototypes.
So they literally had like a golden meter. This is kind of crazy. So like if this was like the golden meter, they had this thing in like a bunker in like Sweden. So I know, it's kind of crazy. If there was like nuclear war, then we would still have the golden meter. Yeah. So what they're about to say is now it's based off of the amount of time that light travels. So that's now based off of the speed of light. But they used to have like a golden meter. They used to have like exactly what a kilogram was stored, but now they don't. But I bet somewhere that golden meter is still somewhere.
But thanks to improving technology and precision, these objects with limited access and unreliable longevity are now being replaced with standards based on universal constants, like the speed of light. Consistent measurements are such an integral part of our daily lives that it's hard to appreciate what a major accomplishment for humanity they've been. And just as it arose from a political revolution, the metric system remains crucial for the scientific revolutions to come.
So how easy would it be to switch from standard to metric? Could we do it here in the United States?
Probably.
You think probably?
I mean,
Who thinks yes, it could happen? Okay, I got a couple optimists in here. Who thinks definitely not? Okay, why not? Why not? Cameron, what do you think? Why not? Jocelyn?
We've been doing it this way for like hundreds of years, so some of us won't know how to do it, but others are learning it that way.
Just because we've been doing something for hundreds of years, does that mean it's right?
No.
Okay. What else?
People don't like change.
People don't like change. I like that. What else? When you get into your car, what does your car say? Miles per hour. What do all the signs on the highway say? Miles per hour. What does every tape measure say that you buy at Lowe's? Inches.
You have to change all of that.
What is our milk? What does our milk come in? Gallons. Think about the money it would cost to switch that.
And it'd be very annoying.
I don't think it'd be annoying. I think it'd be super easy.
For the people that are changing.
Inflation would definitely.
Have you guys seen the Saturday Night Live skit with Nate Bargatze? Have you seen the one where he's President Washington and they're talking about like trying to implement the metric system? Yeah, you guys have to look that up on your own at some point. But like, it's really funny because they're like, it's so funny. Yes.
Did you know that Britain actually uses, like, they have gallon jugs and they use miles in the cars. They also use metric systems and other things.
Yeah, a lot of countries over in Europe, they have both, but it starts with metric. And like if you look at like your car speedometer does have kilometers per hour as well. It does have kilometers per hour. Do I think that this will happen in your lifetime? No, we're not going to change. Because who said we don't like to change? Exactly. We don't like change. But remember, there's lots of things I can think of in the past in our country that happened for a long time that weren't great. So make sure you're having an open mind. The good thing is that we here in the United States use the metric system. Where was this? I think this is it. So we here in the United States use the metric system. So tomorrow we are going to start off here with the idea that 1 foot equals 1 pound equals 1 gallon. I'm going to prove to you tomorrow that you can actually do that in the metric system. Have you guys ever seen it proved? I'm going to prove it to you. So you guys have like 6 minutes left. Nice work today. Did that feel like notes? Oh, sweet. I tricked you into taking notes. Good. So you guys can have the last 5 minutes. Nice work.